Okay, so now we're going to do our final question, which is going to be everyone's favorite, of course, because we all love word problems. So, it gives us that the height of a ball thrown from a balcony can be modeled by the function h of t, and it gives us h of t in standard form, where h of t is the height above the ground in meters at t seconds after it's thrown. So it's asking us to write h of t in vertex form. So again, same thing. I'm going to do it on the separate piece of grid paper so that you can see it better. But I'm just going to copy h of t is equal to minus 5t squared plus 10t plus 35. And now, two things that you want to keep in mind. I know you've completed the square before, but I know I sound like a broken record. I just need to go over it again. You're looking for your vertex form to look like this, right? A x minus h squared plus k. And the other thing you need to keep in mind is because you're essentially, quote-unquote, artificially creating a perfect square, like a binomial squared, you need to be on the lookout for this, right? X plus y squared or x minus y squared. And they take this form, right? X squared plus 2xy plus y squared, or if it's the negative version, x squared minus 2xy plus y squared. So that's what you need to look out for. And the way we do that is, number one, we need our variable inside of our bracket to have a coefficient of 1. So I need to factor out my minus 5 here, right? That's going to be my a. So I'm going to have minus 5t squared minus 2t. And then the plus 35 we're going to toss off to the side for now, because we need to figure out, I'm going to do it in a different color, we need to figure out what our plus y squared is and our minus y squared is, right? Because we're going to group these three up to make our perfect square binomial, and then this will come outside of the bracket to combine with our 35. Now, because we've got a minus here, we know that it's going to be this one over here. I'm going to have x minus y squared, and because I'm a little bit lucky, I've got minus 2t is my minus 2xy. I just need to divide minus 2 by minus 2 to give me what my coefficient of y is, which in this case is nice and easy. It's just 1. And then 1 squared, of course, is just going to be 1 again. So I've got minus 2t plus 1 minus 1, where, again, the positive 1 is going to group with the other two terms to give me my binomial squared, and this will exit the bracket. Okay, so I've got h of t is equal to minus 5. That doesn't change. And then I have t minus 1 squared. And then when the negative 1 exits my bracket, remember you have to multiply it by what's in front. So negative 1 times negative 5 is going to give me a positive number because it's two negatives multiplied together. And 1 times 5 is just 5. So I've got plus 5 plus 35. Of course, you can skip this step. You can just add them together to make 40. But I'm doing it just for clarity. And now we've got our h of t in vertex form. And because the question does not ask you to do any more than that, don't do any more than that. Make your life easy. So, B, what does B ask us? It says determine the domain and range of h of t. So, there's only two things you really need to keep in mind here. That's a little tricky. Because we've got a word problem, we have to keep in mind that, number one, we don't have x and y. We have actual variables. We have h and t, so our height and our time. And we also have to put ourselves in the shoes of that, or not in the shoes, but in that scenario of the word problem to apply to our restrictions. Because, and as we'll see here, our domain, so our independent variable, of course, is going to be time. That's going to be an element of the real numbers. And our restriction on time is just going to be that time has to be greater than or equal to 0. Because we can't have negative time. Now, mathematically, that wouldn't be a restriction because t could be negative here and the function wouldn't be undefined, but because it's a word problem, we have to remember that time can't be negative. And then our other variable, height, is going to be an element of the real numbers where, again, you have to put yourself in the quote-unquote scenario that you're in. We have to think what's the minimum and what's the maximum. So our function has a maximum because this is our vertex. So the highest the ball is ever going to go is 40. And the lowest the ball is ever going to go is not 35, where it's launched from, because even though it's not launched from the ground, it's launched from a balcony, it's eventually going to hit the ground. So it's going to hit 0, but it's not going to start burrowing into the ground. So the lowest our range is going to get is 0. And now we get to the tricky part, is we have to find the inverse of our function, right? Because originally we had a function that gave us height in terms of time. Now we need a function that gives us time in terms of height. Okay, so well, I'm not going to take any minutes, but I'm going to pause here just for 5 seconds, give you a chance to pause the video to try it on your own, and then we can compare answers, or you can just wait a few seconds and then follow along with my solution. Okay, so let's do C. I've got h of t. I need to find my inverse of my function, and I've got two choices. I can work with my function in standard form or vertex form, right? Because it's the same function. It's just written in different forms. But the reason I want to work with it in vertex form is because t only pops up once. Right? It makes my life a little bit easier trying to isolate t, whereas here I would have to factor it, and it wouldn't become a nightmare, but I would be redoing work that I put in just to get it into vertex form. And if it makes it easier for you to understand how we're switching our variables, here we have height. Instead of h of t, I'm just going to write h is equal to minus 5t minus 1 squared plus 40. And the nice thing about this is now I don't have to swap the location of the variables the same way I would where I'm doing an inverse with x and y. I just need to isolate for t, because what I'm looking for, and I'll do it in a different color, is I'm looking for, instead of h of t, I'm looking for t of h. So I'm looking for t to be on its own side, all isolated and alone, and h to be the only variable on the right side of my equation. So all I need to do is take this exact equation and get t on its own. So first things first is I'm just going to copy it, and then we'll start working on it. Okay, so first things first, I want to get rid of the 40. So I'm going to end up with h minus 40, right, because I'm going to subtract it from both sides, plus 40 minus 40, and then it will cancel out. Of course, you don't need to write this. I'm just writing it to be super clear when I'm doing my steps. Then the next thing I need to do is get rid of the minus 5. So I'm going to divide both sides by minus 5, but I like putting my negative in front. So I'm going to have negative h minus 40 over positive 5. You can leave your negative in your denominator if you'd like. And then I'm going to have t minus 1 squared. And now I'm just going to square root both sides. The two things you need to keep in mind, so first I'm going to write my answer, and then I'm going to state those two things you need to keep in mind. Number one, because you square rooted both sides, the plus minus needs to be applied here, right? So I need a positive and a minus, because I'm getting rid of a power of 2 by square rooting it. And the other thing that might sound off alarm flags, or alarm bells, not alarm flags, alarm bells in your head is this minus. And you're thinking, hey, I'm not allowed a minus in my square root, just like in example number 2. But just like example number 2, remember, if this whole thing, h minus 40 over 5, gives me a negative value, then this will be okay, because the negatives will multiply and I'll have a positive underneath my square root. And then the final thing I need to do to get t on its own is t is equal to plus minus the square root of minus h minus 40 over 5. And now instead of a minus 1, I'm going to have plus 1. Okay, so that is the model that describes the time in terms of height, right? It's saying that time is going to be equal to whatever we have. So we would plug in whatever h gives us, and it would give us either two possible values, right? Because we have a plus minus here, two possible values, or in the event where this whole square root is 0, it would only give me one value, which would be 1. So you can already see how this is going to be a relation, not a function, because it'll have scenarios where it'll spit out two different values for t when I only have one value of h. Okay? Now, again, don't worry if any of this confuses you. I know I'm not there in person, but I will be tomorrow when I'm feeling better to answer any of your questions. So finally, D. What are the domain and range of the new model? The nice thing, and the reason I'm doing it up here, I'm actually going to do it in pink so that the colors are matching, but the reason I'm doing it up here is you don't actually have to think almost at all for this. So my new domain and my new range, remember, the domain and range just get swapped because my variables have swapped, but even though my variables have swapped and my equation is different because I'm choosing to represent the same situation in a different way mathematically, nothing actually changes about my situation. It's just my domain is going to be that h is an element of the real numbers with the exact same restrictions, right? Because the restrictions don't magically change. My ball's not going to start burrowing into the ground or going past my maximum. So the domain is now that h is between 0 and 40, but also including those values. And now my range is that time is an element of the real numbers where time has to be greater than or equal to 0, right? Because, once again, how I'm representing it mathematically has changed, but my situation has not. So, of course, the restrictions on the situation can't change. Okay, so that is the whole lesson. I hope you were nice to the supply teacher. Thank you for tuning in to the first and hopefully last episode of Basaraba Math, because I'm not going to do this every time I'm sick, and hopefully I'm not sick again. But just to recap, if you have any questions for me, I will be here tomorrow because I will hopefully be feeling better, if not whenever I'm in next time. But just make sure you do your homework and just take everything one step at a time, because it might look complicated, but what we're doing is just rinsing and repeating what we've been doing before. If we need to find the vertex form, we complete the square. If we need to find the inverse, we swap variables and just do algebra to isolate our new variable, right? Because here we needed to isolate for t, we just did opposite operations. Here I had addition, so I did subtraction. Here I had multiplication, so I did division. Here I had a power, so I square rooted it. Okay, so just take everything one step at a time, and it'll be simple, and I will be back at school soon to answer any of your questions. But hopefully that made sense, and I will see you soon.